Okay, so for question 1, binary representation. For the following Boolean inputs, how many outputs exist? And we have a number of questions, 1, 2, 3, 4, 5, and 6. So how will we go about this? The first thing to note is we are dealing with Booleans. So a Boolean can be true or false. Another way of representing this is with binary. So true would be 1 and false would be 0. Now there's actually a number of ways you could represent this. This could easily just be up and down, down, on, off, etc., as long as it's consistent. And what we're going to focus on is binary representation. So when we're dealing with Booleans, true will be 1, false will be 0. So for a Boolean output, all you can get is a 1 or a 0. So you've only 2 options. That is it. Let's take a look at our question. For the following Boolean inputs, how many outputs exist? So if we have one Boolean input, let's say 5. So our Boolean input is x. Our only options for that input, it can be 1 or it can be 0. So how many outputs can I have? How many available? So we have 2 options. So let's look at the second question. We have 2 Boolean inputs. How many outputs exist? So now let's say we have x, y. Well, we already know x can be 1 or 0. But now we also have y can be 1 or 0. Let's write the answer here. So this can have 2. So now this can have 4 options. X can be 1, x can be 0, y can be 1, y can be 0. If we go to number 3, back to our question, again it's 3 inputs. So now we're going to have x, y, z. Again, 1 can be 0, x can be 1, y or 0, y can be 1 or 0, z can be 1 or 0. Now, you might be thinking that the answer here is actually 6. But you would be wrong. Because when you're dealing with, let's write this out in terms of a table. So let's say we have x, y, z. So let's say x, you can have 0, 0, 0. So when they're all 0. You can have 0, 0, 1. Let's say z is 1. You can have 0, 1, 0. So x can be 0, z can be 0, and y can be 1. You can have 0, 1, 1. So x can be 0, y can be 1, z can be 1. 1, 0, 0. 1, 0, 1. 1, 1, 0. And 1, 1, 1. So what it actually is, you have 8 different outputs. So when you have 3 inputs, you can have 8 different outputs. So depending on your function, this could end up being 0, this could be 1, 0, 1, dot, 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 dot. That just depends on what function you're trying to get. So the actual answer is 8. What I'm basically trying to say is it's not 2 multiplied the number of inputs. It's 2 to the power of the number of inputs. So 2 because we can have a 1 or a 0 as our output, and input is the number we can have. So here we have 1 input, so 2 to the power of 1 is 2. Here we had 2 inputs, 2 to the power 2 is 4. Here we have 3 inputs, so 2 to the power of 3 is 8. As we saw with the table we drew out, there were 8 different options. Because you have to represent all the combinations available for X, Y, and Z. Yes, X can be 1 or 0, Y can be 1 or 0, Z or 1 to 0. But you have to show all the different possible combinations of the 3. Basically, when you're thinking of working in binary, it's always going to be 2 to the power. So you can actually delete these now. So let's look at the next question. 4, 7, and 10 are the next 3 questions. We won't bring up the X, Y, or Z. 4, 7, 10. So our answers for this are going to be 2 to the power of 4, 2 to the power of 7, 2 to the power of 10. And this equals 16. This equals, if I remember, is 128. And this is 1024. And that is the answer to this question. All you really have to remember for this question 1 is when you're dealing with a Boolean variable, it's going to be 2 to the power of the number of inputs. So this is and not multiply number of inputs. If you're dealing with a ternary operator, where you can have 3, you can have 3 options. You can have true, false, and let's say a maybe, could be true or false. Then you would have 3 options, so it would be 3 to the power of number of inputs. But for now, let's focus on the booleans. And that is our answer for question 1.